Alright, as promised, here's the C program. This flashed into the MCU microcontroller for the PDSP display. Now what I have is I have the serial port that comes into the microcontroller. I have that set up on an interrupt right here. This interrupt routine looks for the flag to get set, and then I have a buffer, this RX buffer, and I have basically I have 9 elements in it, and it just constant. Every time there's a byte that comes down the line, it'll trigger the interrupt, and then it'll add the byte into the RX buffer here, which I have set to UDRO register. So the bytes are coming down the line into the microcontroller, and the interrupt gets triggered, and the byte comes into the UDR register, and then it gets dumped into the RX buffer. So each byte that comes down from the C# program goes into this RX buffer, each element 0 through 8, and then it resets. When it gets to 9, I reset the RxN here, goes back to 0, and does it again. It keeps looping around and around, dumping the bytes into the RX buffer. Anytime it receives a byte coming down the line, it triggers the interrupt, dumps the byte into the element, and steps through each time, and continually loops all the time. When it's receiving a byte, it gets triggered. Now in the main program, the main loop here, which was going to run all the time, right here I have I'll explain this other part here. That's for the missile launch. And basically the main loop is looping around constantly, and it's running this right shaft 9-digit method with the RX buffer as a parameter. So going down to that right shaft 9-digit method right here is basically a pointer that's looping through the array, because remember I put RX buffer in here as a parameter. So it goes in, the pointer is set to the first element of the RX buffer array, and it dereferences here and says, okay, what's the value in the first element, and say if the chaff counts 180, the first byte coming down the line is going to be a 1, a hex 1. It'll come in here and put the first element 0. It'll put a hex 1, and this will dereference it and say, okay, there's a hex 1 in here, and then I use the character single 0 mode, which I wrote in my earlier videos, and displays that 1 on the display, and then the pointer increments to the next element, which would be 1, and there's going to be a byte 8 coming down, because say if the chaff is 180, the next one's going to be an 8, ASCII 8. It'll come in as a hex number, and the pointer will be pointing to it, and then it'll dereference it, and then the method will write 8 out to the display, and then it goes one by one and loops through this thing all the time too. So because the main loop is looping all the time, and then it's calling this method on this function, and so it'll step through each one of these. And so the first 3 I have set up as chaff, and then I have the diamond character, which stays on all the time. I need to make this flash, haven't implemented that yet, but that's what this 4th one in the element of the array is. And then there's 2 blank. I send 2 hex codes for running blank on the display, because the 2 digits next to the diamond are blank. They never show any characters. And then here is the tricky part. I added a dummy, kind of a dummy iteration right here. This is where the missile launch code comes across the line and goes into the array. So the missile launch code goes here. And obviously I don't want to display that. I just want to send that to another part of my program to light up that LED. But I need to keep the pointer incrementing in synchronization with the array. If I don't put that in, it'll get out of sync, and it'll start acting all squirrely because the step-by-step count is messed up. And then the final two are for the flare. The final 2 digits here are the flare. And like I said, this method is getting called in the main loop. Right here, getting called constantly, going over and over and over. So anytime a byte comes down the serial line, the interrupt will write that byte into the RX buffer here, and then this method, because it's constantly being called, it'll update it. So basically on the display it looks like it's not flashing, it looks steady all the time, but it's actually redrawing constantly the numbers, but you don't see it with your eye. It looks like it's steady, and then it just draws the changes. Now part of this loop is the missile launch flash. So down in the interrupt right here, I'm looking for that bit. Remember that dummy bit coming down? I just made any one up that I'm not using in the ASCII chart, so then I won't be using on the display. And so it looks for 0x9 come into the UDR, come down the UDR and be put into the buffer. So as soon as it sees that, then it changes my flag to 1. Go up to the main loop. If my flag is equal to 1, then it'll launch. It'll call this missile launch flash method, and it'll flash the red LED that a missile launch is coming in. Missile launch method. There it is here. Just a simple XOR function with a delay. May have to change this, because it slows down everything. But right now it works, so I'm just getting the basic functionality to work, and worry about refining crap later on. Here is the mode button. Okay, this is for the encoder. I haven't implemented this yet. And here I have this is for the mode button. So if the mode button gets pressed, it's wired up into the display, so that it pulls the ground, pin 6, and basically I just have a case statement set up, so each time I press it, it'll just cycle through the different modes and display the string on the other display. So off, standby, on, SST mode. So that's simple. More work needs to be done on this because of the delay. I put a delay in for button debouncing, but I need to put proper software debouncing in from newbiehack.com. I'll just use his function and put it in here. I've got to get rid of these delays. It's causing some problems, slowing everything down. And let me go over to the C# program. Alright, C# program. Quick review. Remember we put we'll put a reference in here for Lightning's DLL, F4 shared mem DLL. Put a reference in so we can use all of his implemented methods. All his implemented methods on the flight data, and of course we're just interested in the chaff count and the flare count, which were float numbers, All I set up is a simple stop button and a start button. Just basic functionality for testing. I got a couple boxes. One shows that the missile launch is active or it's inactive, and then I have the chaff and flare count in the other boxes, just as a backup to check, make sure that the cross reference, the things are coming, are being printed from the captured from the simulator, and that the C# program is capturing them, and then I can cross-reference with the display, see that things are displayed. Covered some of the stuff before. Important things: my chaff count, my flare count. I have my missile launch. Here's the start button. When I click on it, it'll create an instance of the reader class in Falcon, and I have up there's a Boolean set up to keep this loop running, where it's constantly scanning the data. As long as Falcon is running, it'll constantly scan the data coming in through the object, the flare count and everything else. In our case, we want the flare count and also the light bits too. This is for the missile launch. When this is a 1, it detects a missile launch. When it's a 0, there's no missile launch. So as far as the missile launch goes, whenever you're ANDing something to like a register, I assume this is a register, you're getting the output of that bit, of that single bit. In this case, we just want the one bit. This register will have a bunch of different bits in it for different data, but we're only interested in one bit, and it's the missile launch bit, which if you look in the header, which I gave a link to on EWPIBuildup, or the header file, you can see the definition for missile launch. The hex number is 2. So when this is ANDed with the light bits, that the 2-bit is passed through, all the other bits are blocked. We're not interested in them. We just want to know what that missile launch bit is doing. Is it high? Is it low? If it's high, it'll write missile launch to text box 3. It'll turn my launch to true. If it's not, if it's a 0, it'll be a no launch. I'll write that to the box, and a false on the Boolean. Alright, I'll get the rest of that further down. Serial port. This is all setting up our serial port between the our USB to serial converter. Setting up our parameters using the built-in serial port class. You set your parameters: COM7, baud rate 2400. And then here we open the port up. Now once the port is open, we've got communications established with the MCU, and first thing I'm checking here on my outside loop is, do I have a missile launch indication? If I do, then I'll start running through this loop here. If I don't, there's a loop down here, right here, that is false, and I'll do this section here. Basically, I have a lot of this is written out. I need to tighten this code up a lot, but just to get functionality, I copied everything out in duplicate. So I've got like this all could probably be written in one method. But I'm running out of time here, so see you in the next vid.